Now we'll go on to the next theory we're looking at, recognition by components theory. This theory basically says that we recognize objects based on these shapes that are within the object, almost like putting together puzzle pieces to form, an image. And so the shapes are these components, and so we recognize objects by recognizing the components or shapes. And so here in this picture, we can see 3 examples of these components. One here is a cylinder. This one's sort of a, kind of a horn-shaped object. And here's one that looks like a wedge of cheese. These are called geons. So these components have a term. The term is geons, which comes from geometric icons. Now, what we need to know about geons is that these shapes are, number one, 3-dimensional. So number one, they're 3-dimensional. The other point about geons is that they have what's called viewpoint invariance. We can recognize an object or a geon within it, even when we are looking at that shape or object from a unique perspective or a unique viewpoint. According to viewpoint invariance, we can recognize the cylinder shape when we're standing and looking at it from this direction, or here head on, or here looking at it from the left instead of from the right. So regardless of where we're standing in relation to the cylinder shape, we will recognize the shape equally well. Same thing here with the shape in the middle, and same thing here with this shape here at the bottom. If we can imagine if this was, a 4-foot tall object and we were able to sort of walk around it and look at it from different perspectives, we would be able to recognize it from every one of those perspectives. And that's what viewpoint invariance says, that we could recognize the geons and the object from any viewpoint. Here's a nice example of how geons fit into common objects. So here's a coffee cup, has the cylinder, has this little arch shape for the handle, a lamp, the paint bucket, flashlight, suitcase. And so the geons are going into this object and helping us recognize the object, because the idea is that we see the geons and recognize them, and then we put them together and say, okay, so what object has this combination of geons? Oh, it must be a flashlight. And what object has this combination of geons in this setup? Oh, it must be a coffee cup. Now, one question is, how do we recognize objects even when they are partially covered up by something else? And it turns out that we can still perceive most objects if we can see most of the geons. And that's the principle of confidential recovery. So as long as most of the geons are visible, we will be able to recognize the object. So here we have 2 examples. On the left and on the right, there's an object. What's different is on the left, the corners have been blacked out, making it hard for us to see the shapes, making it really hard for us to figure out what the geons are in this object. In this object here, it turns out that it's actually the same object. The edges, the corners and such, are visible. That allows us to infer the geons that go into this, and it makes it a little bit more likely that we will be able to sort of connect the dots here. Remember our Gestalt principles? We will be able to fill in the lines and recognize the different geons that go into it. Like, oh, this is a cylinder. Here we have sort of a rectangular sponge shape, and so on. and figure out that maybe here we're looking at a flashlight. Much easier here on picture B on the right. Very difficult to do that here on the picture on the left. Also notice the picture on the left, it just doesn't have much depth information, again, because the edges of the geons are all missing. And so it turns out that we need about half of an object's geons for people to recognize the object a majority of the time. So again, the idea that we can recognize an object even if we don't see all of it, so long as we can recognize the geons that make it up, is the principle of confidential recovery. Now take a look at this object. This is actually a fairly common household item, but it may be difficult to recognize. We're just looking at it from an unusual perspective. And I show this to you to challenge the idea of viewpoint invariance. So remember viewpoint invariance. We can recognize an object or a geon even when an observer changes their viewpoint. What do you think it is? It looks like a knob, maybe? Now it's easy to figure out what it is, huh? So using a more common perspective or more common viewpoint makes the object much easier to identify. So, do we always have viewpoint invariance? No. And that is one limitation of recognition by component theory. So here's how this recognition by components theory works. We see the object, we identify the geons within the object, we combine the geons together to identify objects, and we recognize the object then. So this little flowchart just kind of describes how the RBC approach works. Now, how can geons help us distinguish between similar models of cars, for example, that might all have the same geons? I mean, if you are driving on the road, you look around when you're stuck in traffic, and I bet you a lot of the cars look really similar. So, can RBC, recognition by components, tell us, explain how we recognize the difference between a Toyota versus a Honda versus a Ford SUV? It might be really difficult because many different types of cars probably have the same geons because they have the same shape. Same thing here in distinguish between zebras versus horses. There are some differences like in the ears and so on between zebras and horses, but their overall shapes are really pretty similar. And I'm betting that for most people, it's not the geons that help us identify a zebra versus a horse, but the stripes. So the RBC approach does have some limitations because of that.